Okay. Okay. So, good morning to everyone.
Good morning,
we are
sir.
talking about the standard deviation. So, as I said in the last class, to understand the correlation, okay, to understand the concept of the correlation and regression analysis, standard deviation must be understood. Okay, standard deviation must be understood. So that's why in today's class, we are going to be discuss the standard deviation. The standard deviation. This standard deviation is one of the important aspect in the dispersion. Okay, in the dispersion part, this standard deviation is one of the most important concept. Okay, in this standard deviation, this concept.
దీని నడిచింది వైట్ ఇది ఉంది గ్రీన్ ఇది ఉంది రెడ్ ఇటు గ్రీన్ చెప్తారు.
Okay, this standard deviation, okay, this concept was developed by Carl Pearson. Okay, you know, this concept, whatever we are talking about this standard deviation, okay, this concept was developed by the Carl Pearson. The person, he belongs to Britain, so he was developed this concept. So this standard deviation is very important aspect, and it is going to be used widely to measure the dispersion, that is variation, to dispersion and variation. So its significance lies in the fact that is free from those defects from which the earlier method suffer and satisfies most of the properties of the good measures of the dispersion. Okay, in the before the standard deviation, there are many measures, like we have range, we have quarter deviation, Okay, we have the mean deviation. Okay, before that we have the central tendencies. Whatever the defects we see in that methods, so that defects can be minimized. So with the standard deviation. So this standard deviation is also known as a root mean square deviation. Okay, it is called root mean deviation. Okay, for here, why it is called root mean square deviation? For the reason that it is the square root of the mean of the square deviation from the arithmetic mean. So whenever we are talking about this standard deviation, it is the square root of the deviation taken from the arithmetic mean. One of the basic method in the statistics, that is arithmetic mean. So from that arithmetic mean, we are taking the deviation, we are taking the variation. For that value, we are going to take the square root value. So that's why it is called the root mean square deviation. So the standard deviation denoted by the small Greek letter called sigma. Okay, this with this letter we are going to be discuss the standard deviation. So that letter we are going to be read as a sigma. Okay, it is a sigma. So like a sigma, we are going to be discuss this point. Then the standard deviation, it is going to measure the absolute dispersion variability of the distribution. Okay, the greater the amount of the dispersion or the variability, the greater the standard deviation. So whenever there is a greater deviation, we can say that standard deviation is more. Like the smaller, greater will be the magnitude of the deviations of the values from the mean, that is arithmetic mean. So a small standard deviation means a high degree of the uniformity. See, if we will get the standard deviation value is less, we can say that there is a greater uniformity among the variables. Okay, among the variables, so we will have the uniformity, greater uniformity. So more standard deviation, less uniformity among the variables, whichever given in the data. Okay, less standard deviation means, so there is a more uniformity. More uniformity means less variation, less variance, less dispersion, less differences among the what is called variabilities. So that means it can be observed as a homogeneous of the series. Homogeneous, nothing but we can have less dispersion, more uniformity. So a large standard deviation, just the opposite. Okay, it will be vice versa, like. Okay, yeah, if we have two or more comparable series with identical, newly identical means, it is the distribution with the smallest standard deviation that has the most representative means. Okay, hence the standard deviation is extremely useful in the judging the representative of the mean. So it is the representative of the mean, we can say. Okay, that is the point we can observe here. Okay, then how we are going to calculate the standard deviation? Standard deviation. So as we discussed in the many classes, the standard deviation, nothing but, okay, it is going to be used to measure the variance among the variabilities, and it is the most important variation, variability, dispersion to measure the, to understand the variation among the variabilities. Okay, so here this standard deviation, like other variants like range, quartile deviation, like central tendencies, that is arithmetic mean, geometric mean, harmonic mean, median, mode. This standard deviation also calculated with 3 series. That is indivisible series, discrete series, and what is called continuous series. Okay, in today's class, we will try to discuss that how we are going to calculate the standard deviation with indivisible series. Okay, so the calculation of the standard deviation with indivisible observations. Okay, that is indivisible series. So how can you find out that whether it is in the indivisible series or discrete series or continuous series? We have so many measures. Okay, if there are only x values were given in the distribution without frequency, that will be known as indivisible series, indivisible observation. If we have the x values along with the frequency, then we can say that what is called, this is there in the discrete series. If there is a class interval along with the frequency, then we can say that this is in the form of the continuous series. Okay, what is called continuous series. Okay, here indivisible series or indivisible observation, nothing but we will have only x values. There will not be frequency. Okay, without frequency, only x values were given in the distribution, in the data, that will be identified as indivisible observations. Okay, so in case of the indivisible observations, the standard deviation may be computed by applying any of the following methods. So there are many methods. So any one of the following methods we can apply to measure the standard deviation. So that is by taking the deviation items from the actual mean. Actual mean. So actual average. Actual mean or actual average. Like that is central tendency. Either we can take the arithmetic mean or median or mode generally. Okay, most popular method is arithmetic mean. So by taking the deviation of the items from the actual mean, popularly we can say that arithmetic mean. So please remember here, we can take the mean, we can take the average from the mode and median also, but popularly it will be calculated with arithmetic mean. That please remember. So by the taking the deviation of the items from the assumed mean, okay, this actual mean, nothing but it is called standard deviation. Okay, standard deviation. Please remember, assumed mean. What type of the mean you are assuming? Arithmetic mean generally. Okay, arithmetic mean we are assuming. So for taking the deviation of the series from the actual mean, so it is a deviation of the items from the assumed mean. Assumed means arithmetic mean. So the deviation taken from the actual mean means standard deviation. So when the deviations are taken from the actual mean, the following so the formula we can use. Okay, we can use the formula. So here, please remember that actual okay. So whenever we are calculating the standard deviation, the following steps we have to follow. That is, first we have to take the deviation of the items from the actual mean. Okay, actual mean we have to. So that is here actual means arithmetic mean, no doubt at all. How we will find out the arithmetic mean in the individual series? So we have one formula that is sigma x by n, okay, which may be known as the x bar. Okay, x bar. So this is the formula to know the what is called mean. Okay, here by calculating this sigma x by n, we will get one value. Okay, value. So that may be known as the actual mean. And by taking the deviation of the items from the assumed mean. Okay, in the given in the distribution, so we will have the x values, that x values minus the actual mean. That is, we can say that x minus x bar. This may be known as the deviation. Please remember. X means whatever the value was given in the distribution. X bar nothing but actual mean. That is sigma x divided by n. Sum of observation divided by number of observation. N nothing but number of observation. Sigma x nothing but sum of observation. So by calculating this, by using this formula, we will get the x bar. So then we will get the deviation. Okay, deviation. So the deviation is taken from the actual mean. When the deviations are taken from the actual mean, so then the following the formula we are going to be used. So this will be maybe formula. Okay, this will be the formula. That is like okay, sigma. This is called sigma. Nothing but standard deviation is equal to sigma x square root of sigma x square divided by n. Okay, x square divided by n. Sigma x square divided by n. So whereas x nothing but, so x nothing but, so that is a deviation. Here x nothing but a deviation we can say. So that is x value minus x bar. X bar nothing but arithmetic mean. X nothing but the values given in the distribution. So this is the deviation. Deviation from the x values and mean. Then we will get x or d. Either x, we can say it is called d. In some textbooks we can say x, in some textbooks we can say d. That is deviation. Okay, this deviation. So that's why here we can say that but the root of square root of, please remember, square root of mean, we know. So that's what mean nothing but sigma x by n. For that square, for that root. So that's why square root of the sigma x square by n is the formula to know the what is called standard deviation. Okay, in this aspect, so we are going to be see that what are the methods we are going to be used to calculate the standard deviation. So first we have to calculate to measure the standard deviation, we have to calculate the actual mean of the series, that is called x bar, we know. Okay, that is called x bar. And take the deviation of the items from the mean, that is from x bar, what is called x bar, and denotes the deviation by the x, it is called x or d. Okay, we can call x or what is called d. Either x or d we can take and square these deviations and obtain the total value. Okay, whatever the d value you are calculating, that is x minus x bar. Okay, for that d we have to do the square these deviations and obtain the total. So then divide the total number of observations, that is n. Total number of observations nothing but n, and extract the square root. by using this formula, and then we will obtain the standard deviation value. Okay, this deviation was taken from the assumed mean, you know. Okay, when the deviation was taken from the assumed mean, okay, the following formula going to be used to estimate the standard deviation. Okay, finally, please remember this formula. Standard deviation. Okay, to estimate the standard deviation. Okay, to estimate the standard deviation. So this will be the formula, that is sigma is equal to square root of sigma d square by n minus sigma d square by n whole square. Okay, this will be a formula to understand, to estimate the what is called standard deviation. Finally, please remember this formula. Okay, whatever I told you till now, this is the theoretical part. Okay, the theoretical part may not be important, just for understanding only that is important. But the calculation methods is very important in the statistics. So in the calculation methods, so this should be formula. So that is sigma is equal to sigma d square by n minus sigma d square by n whole square. That is for a whole thing, it should be the square root. So here, the take deviations of the items from the assumed mean, that is maybe arithmetic mean, x bar, we can say. Okay, arithmetic mean or x bar, we can say. So that is take the deviations of the series from the assumed mean, that is obtain x minus a. A means assumed mean. We can say x bar. Denote these deviations by d. Okay, d. So that is d is equal to x minus x bar. We can say that is assumed mean. Okay, d is equal to x minus a. A nothing but assumed mean. Assumed mean nothing but x bar. So then we will get the sigma d. Okay, after calculating the d, all the d values we have to add together. Then we will get the sigma d automatically. Okay, so this whatever the sigma d we are getting, the square these deviations and obtain sigma d square. Okay, first based on this formula x minus a or x minus x bar, we will get the d values. The d values we have to go for the square. Then it will be called d square. So if we add together all the d square values, we will get the sigma d square. So then the substitute the values of the sigma d square and sigma d and n. N nothing but here number of observations. Okay, n nothing but number of observation we can see. Okay, see, we will try to understand one exercise here. Okay, exercise. So that is first the x values in the standard deviation. X values was given. So since only x values was given here, we can understand that this was there in the individual observations. Okay, it was there in the individual series only. Individual series only. Okay, these are the 240, 260, 290, 245, 255, 288, 272, 263, 277, and 250. Forget about this one. So this is called sigma x. Okay, why we have to estimate the sigma x. So because to estimate the standard deviation, first we have to calculate the deviation first. Okay, how we will find out the deviation? Deviation is nothing but x minus x bar. X minus x bar. Otherwise, we can say that D is equal to x minus assumed mean. Assumed mean. Okay, this assumed mean or this x bar nothing but arithmetic mean. Arithmetic mean. See, already told you, in the place of the arithmetic mean, we can also use median and mode also. We know already how we are going to be calculating this arithmetic mean or median or mode. Already we discussed in the previous chapters. Okay, here we are taking from the assumed mean, nothing but arithmetic mean we are taking. Okay, so that is x bar. What is the formula to know the x bar? Sigma x divided by n. So that's why to calculate this x bar, we have to understand, we have to calculate the sigma x. Okay, sigma x is required. So that's why we are taking the sigma x values here. So that's why if we add all these values, we will get to 2640. Okay, we know that x bar is equal to sigma x by n. So then x bar is equal to sigma x, nothing but if we add all these values, we will get 2640. 2640 divided by what we can say that n nothing but number of observations. How many there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are there. Okay, by 10. So x bar is equal to 264. This is called assumed mean. Okay, 2640 by 10, nothing but 264. So that's why we know now x bar. Then we have to find out the deviation. Deviation nothing but x minus x bar. So okay, deviation x minus x bar. Otherwise, we can say that x minus x bar. How much x bar? 264. That's why x minus 264. Okay, this is the x. So this is the 264. 240 minus 264, nothing but minus 24. Okay, the point is 240 minus. Okay, 264. So 240 minus 264. So that is minus 24. Okay, then 260 minus 264 minus 4. 290 minus 264, that is plus 26. This is called plus. Then 245 minus 264 minus 19. 255 minus 264, nothing but minus 9. 288 minus 264, nothing but plus 24. 272 plus minus 264, nothing but plus 8. 263 minus 264, nothing but minus 1. 277 minus 264, nothing but plus 13. And 250 minus 264, nothing but so we can say minus 12. So if we add all these values, so we will get minus values and plus values. So finally we will get a 2. This is called 2. Please remember. Okay, sigma D is equal to, we have 2. So we have the 2. Okay, then now if we what we have to find out the sigma D square. Okay, so this D values we have to go for the square. 24 square, nothing but 576. Minus into minus plus, so plus 576. 24 square, nothing but 16. 26 square, nothing but 676. 19 square, nothing but 361. 9 square, nothing but 81. 24 square nothing but 576, 8 square nothing but 64, 1 square nothing but 1, 13 square nothing but 169, 12 square nothing but 144. The total sigma d square is equal to 2664. Okay, so sigma, please remember here, sigma d is equal to sigma d square. How much it is? 2664. 2664. Then what is the formula to know the what is called this one? Hey, ఎవరు మనిషివే కాదువరే ఇష్టం లేకపోతే డిలీట్ కావోయ్ ఎవరు కూడా ఆన్ చేసింది ఎవరు మీరనే చెప్పండి ఎవరు ఆన్ చేసింది ఎవరు వేస్ట్ నా కొడుకులు Okay, this is the formula we know, that is sigma is equal to sigma d square by n minus sigma d square by n whole square. For this one the square root. So we know the sigma d square, how much? 2664. n nothing but number of observations, how many? 10. Okay, if we substitute this values, we will get. Okay, so this is please remember, okay, this is sigma is equal to 2664 by 10 minus sigma d square, how much we have? So sigma d, okay, this is only not square, only d. Sigma d is equal to only 2. That's why 2 by 10 whole square. Okay, 2 by 10 whole square. Okay, then 2664 by 10, nothing but 266.4. Okay, we will get 266.4 minus 2 by 10 whole square. Okay, then the square root of 266.4 minus 0.04. Then sigma is equal to 266 minus what is called 266.4 minus 0.04, nothing but 266.36 square root. So if we will take the square value for this one, we will get 16.32. Okay, the standard deviation is 16.32. Finally, we will get 16.32 value. Okay, this is the point we can see. So when we are talking about this standard deviation. Okay, on the standard deviation, please, if you have any doubt, please ask me. Okay, in the standard deviation, please, if you have any doubt, please ask me.